So chapter 5, polynomial functions. What we're going to look at in this chapter is we're going to divide polynomial functions as a means to factor a polynomial expression. And if we can factor a polynomial expression, we can then find the zeros of that polynomial function. So when we're talking about polynomial function, we're talking about to the power of 3 or to the power of 4, to the power of 5. But most of the stuff that we'll be factoring would be like an x to the power of 4 or an x to the power of 3. Quadratics and linear functions, we've already done factoring of those to find zeros. We just move it a step forward. So just to review what a polynomial function is, this is the official definition of a polynomial function. So all these A's stand for coefficients. So those coefficients are they're real numbers. And then we have our variables, our x to the power of n, x to the power of n minus 1, n minus 2, until we get to x squared x, and then the constant term on the end. My exponents have to be whole numbers. If I do not have a whole number, I no longer have a polynomial function. So if I have x to the power of 1.7, it's not a polynomial function. Okay? I talked about the constant term. That's the term that doesn't have a variable with it. The highest exponent becomes the degree of the polynomial. So the quadratics that we looked at last year were a degree of 2. The linear functions that we looked at in grade 10 are a degree of 1. Okay? So if we look at class example number 1, we have f of x equals x cubed plus 7x, x to the power of 4 plus 7x cubed minus 8x squared plus 5. So what is the degree of this polynomial function? 4. Because that's the exponent. That's the highest exponent. What is the leading coefficient?
1.
Pardon? 1. The leading coefficient, I look at where the highest exponent is, and I look at the coefficient of that term. So it's not the largest number, it's the coefficient of that degreed term. And what's the constant term?
5.
Good. Okay? So class example number 2 just asks us to look at these and state whether or not they're a polynomial function. So what you're looking at is you're looking at one of two things. It is a polynomial, to eliminate polynomial functions, we look at two characteristics. Look at the exponents on the variables. If the exponent is not a whole number, it's eliminated. Okay? So it can't even be a negative. It has to be a positive number. And the other thing that we look at is we look at the coefficients and we make sure that they're real numbers. Okay? They can be irrational numbers, so I could have pi times x cubed. That works. But I couldn't have negative root 3 times x cubed, because negative root 3 is the square root of negative 3 is not a real number. So if we look at class example number 2, I have negative 5x cubed plus x to the power of 1/2 minus 4. Is this a polynomial function?
No.
Why not, Jessica?
Because it has x to the power of 1/2, which isn't a whole number.
Right. So that x to the power of 1/2 is not a whole variable, a whole exponent. Okay. B, is that a polynomial function? So look at my exponents. Are my exponents whole numbers?
No, because of the negative one.
Negative 1's not a whole number, it's an integer. Okay? So negative 1 is not a whole number, therefore that's not a polynomial function. Okay, what about C? X to the power of 4 plus 9,029x cubed minus root 17x squared plus 3,897. So are my exponents whole numbers? Yes. Are my coefficients real numbers? So is root 17 a real number? Yes. Okay. What about D? Which term on D is causing us to look at it?
Probably the root 5x cubed.
Okay. So that root 5x cubed, I can split it up as root 5 and then root x cubed. Is root 5 a real number? Yeah, it's okay. Is root x cubed going to meet my parameters of my variable? So remember in grade 10, when we wrote radicals as a power, the square root of x cubed becomes x to the power of what?
It was not 1/3.
It's not 1/3. What's the index?
Oh, 2.
2. And the exponent is 3, so it becomes 3 halves. So now that we know what the exponent actually is that a polynomial function? No, because I have a non-whole number. So if we look at question 4, or sorry, not question 4, E for question 2, the one that we have to pay attention to is this square root of 3x squared. So if I split it up like I did the last one, I get root 3, which is a real number, and then I get root x squared. What is root x squared? It's equal to x. So is this a polynomial function? It is. Once I simplify it, it actually is, because this x I can then combine. Well, it wouldn't be nice to combine, but I could put them together. So yes, this is a polynomial function. If I look at f, I have a square root of 3, which is a real number. I have an x cubed, which is a whole number. I have this x, which is outside the radical, so that it's okay, it's a whole number. But then I have the square root of negative 3. Is that a real number? No. So this is not a polynomial function. And the reason for that is, the square root of negative 3. I can't have. Okay? If we look on the following page, it's just looking at the degree, the leading coefficient, and the constant term. So sometimes a polynomial function can be in disguised form. So we're going to look at the degree, the leading coefficient, and the constant term of each polynomial function. So if I look at this one, what is the degree? 3. So it's not written in descending order. The x cubed was actually the second term. So then when I look at the leading coefficient, I have to go to that term, and what would my leading coefficient be?
Negative 25.
And the constant?
Negative 39.
Okay. How did you do B? Okay, when I expand it out, 10x squared minus 33x minus 7. Okay, so what's the degree?
I got 30. Did anyone else get
Oh, not
minus 37?
Nope, because it would be positive 35 and negative 2.
So it should be plus.
Oh, plus 33. There we go.
Yeah.
So my degree would be
2.
2. Leading coefficient,
10.
constant.
Negative 7.
So in this form right here, how could I have gotten my constant term?
Could you just
Multiply the two constant terms. How would I get that leading term? I multiply my two largest variables. That's going to give, because when I multiply them together, that's going to give me my x squared. Okay? So if I look at class example number 4, class example number 4 says, in the following, determine the degree, the leading coefficient, and the constant term without expanding, and then verify it through expanding. So if I look at the constant I get by doing what? Multiplying those constant terms. So if I look at this equation, 2 is a constant, 1 is a constant, and this -1 is a constant. But when I go to multiply them together, what do I have to do to the -1? Square it. So -1 squared is, times 1 is, times 2 is. So my constant term should be 2. To get that leading coefficient and that degree, I'm going to take the x term, and I'm going to square it. So 3x squared would give me 9x squared, which I then am going to multiply by 5x squared, because that's the next highest, because I'm going to have to take this and multiply it by that eventually anyways. So when I multiply it by 5x squared, I will get
45x power 4.
and then I still have to multiply it by 2. So I will get 90x to the power 4. So that means my degree is 4, and my leading coefficient is 90. So if I go to expand this out, the way that I would probably expand it out to save me some time, the 3x minus 1 all squared, I can do that one kind of in my head. I square the 3, I get 9x squared. Then I'm going to take 3 and multiply it by -1, and I'll double it. And there's my -6, and then plus the 1. And then I'm going to take this 2 and I'm going to multiply it by everything inside of here. So 10x to the squared minus 2x plus 2. And then I'll distribute this all up. So the 9x squared gets multiplied by everything inside the brackets. 18x cubed plus 18x squared minus 6x cubed plus 12x squared minus 12x plus 10x squared minus 2x plus 2. And then when I add it all together, there's my 90x to the power 4 that I got in the first place, minus 24x cubed plus 40x squared minus 14x plus 2. Did I do something wrong?
I got everything except I got -78x cubed. I don't know how.
So I get 90, 18, oh right here, 60. There we go. So yeah, -78x cubed. 60x cubed minus 10. Okay, so if I look at B, how does B differ from A?
Plus instead of multiplying.
Plus instead of multiplying. So if I try to do this without expanding, when I expand, or when I think about my constant term, I'm going to take the -1 and square it, which is going to give me a +1. And then I'm going to multiply that by 2, which will give me 2. And then I'm going to add it to the other constant term, which would then give me 3. When I look at my degree, I'm going to take that 3x, and I'm going to square it to give me the 9x squared. I'm going to multiply it by 2 to give me the 18x squared. But now I'm adding it to the 5x squared. I'm not multiplying it. So I get 23 coefficient of 23. So this time when I go to expand it out, I would have 2 times this 9x squared minus 6x plus 1 plus 5x squared minus x plus 1. So I'd multiply the 2 in, remove the bracket, and then collect the like terms. 23x squared minus 13x plus 3. So if I look at class example number 5, I have this polynomial function where p of x is equal to 7. Why does this function have a degree of 0?
Is that like a constant term?
It's a constant term function. So because it's a constant term, it means that it has no variable. But what if I told you that you live in the land of variables and everything that you write has to have a variable in it, otherwise you're punishable by, I don't know, 28 days in the stock. So if I had to write this with a variable, what could I put in there to make sure that my 7x something would still be equal to 7? Because what is x to the power of 0? 1. Since x to the power of 0 equals 1, all I've written is 7 times 1, which is just 7, so why do I need to put the x to the power of 0? But that gives me my explanation. Why does this have a degree of 0? Because my variable would actually be a degree of 0. Okay, we can classify polynomial functions by the number of terms and by the degree. Number of terms, a monomial, binomial, trinomial, 1, 2, and 3. Anything more than 3 terms, we call it a polynomial, although they are all polynomial. But if I give you specifically a binomial and say what type of polynomial it is, you have to say it's a binomial because it has 2 terms. By degree, we've already just talked about the constant. We talked about linear functions in grade 10. They have a degree of 0. Quadratics were the ones we did last year with a degree of 2. If it has a degree of 3, we call it a cubic. And a degree of 4, we call a quartic. And that's really what we stop at. We don't classify anything higher than a degree of 4. So if I have p of x equals c, this is a constant function. It's going to have a degree of 0, and it's going to be a constant. P of x equals ax plus b, so that's my mx plus b. That has a degree of 1 because my exponent is a 1, and this is linear. Ax squared plus bx plus c has a degree of 2. And what do we call it? What do we call it? Quadratic. Ax squared plus bx squared plus cx plus d has a degree of 3. And we call it, and ax to the power of 4 plus bx cubed plus cx squared plus dx plus e has a degree of, and we call it, why do I have a cannot be equal to 0 in those 4 rows?
Because then wouldn't the degree not be that?
Yeah, if a is equal to 0, it eliminates that front term. So then I would have a constant, or then I would have a linear, or then I would have a quadratic, etc. So that's kind of the limitation, is that the first term can't be equal to 0. Otherwise it changes what I have. And then we can classify polynomials based on the type of coefficients that they have. 3x squared minus 5x squared plus x plus 7 is called an integral polynomial function. Why the word integral?
Because it only uses integers.
Integers. Because I have negative and positive whole numbers. 3x to the power of 4 minus 2/5 x squared plus x plus 7 is a rational polynomial function. Why the term rational? What gives this function its rational classification? What value? And why is it the 2/5? What kind of number is 2/5? It's a fraction, and a fraction is a rational number. The definition of a rational number is I can write it as a fraction. So decimals would be also included in this. Terminating and repeating decimals would be in this classification, because I can write terminating and repeating decimals as a fraction. And then the last one, root 3x to the power of 4 minus 2/5 x squared plus x plus 7 is a real polynomial function. Why is it a real polynomial function?
Is the root 3?
Yeah, root 3 is a real number. Okay, and it's one of those things where, yeah, every polynomial function would be a real polynomial function, but we classify them based on the minimum that they meet. So in each case, we want to write a polynomial function that satisfies the following conditions. So I'll do the first one for you, and then I'll get you to do 2 on your own. Keep it simple. Don't try to get creative. It's a trinomial. How many terms do I have? 3. 1, 2, 3. It's quartic. What does that mean? Degree of 4. So that means I have to have an x to the power of 4, or an m or an a, or whatever letter I pick. And it's integral. What does integral tell me? So positive and negative numbers. So I could go plus 3x minus 7. I can put a number in front of the x to the power of 4 if I want, or I can just leave it like that. That meets the conditions. It is a trinomial, it is quartic, and it is integral. So do B and C. Okay, binomial, linear, and real. Give me an example.
X plus root 3.
Wow, we copied.
There we go. It's a binomial. It's linear, meaning that your x has to be to a degree of 1. I could have also had the root 2 of x minus 7. There's lots of things I could have had. Okay? A monomial that is quadratic and rational.
1/2 x squared.
I had 1/3.
1/3 x squared would
It's
work
meant to
too.
be.
Yeah,
It's the same, right?
yeah, but
Don't argue with each other. You both got it right.
What did you put? I had 1/3.
Okay.
Not
Evaluating unknowns in a polynomial function. If p of x equals negative 3x squared plus ax plus 8, and p of 1 equals negative 9, what's the value of a? So p of 1 equals negative 9. That's part of those composite functions we did in chapter 1. When x is equal to 1, p of x, which is this, is equal to negative 9.
Oh yeah. Doesn't the 1 have to? Oh, but it's the same thing.
It's the same thing.
That's what.
I have the 1 after it to show that I was replacing it for the x. I'm negative 3 times 1. Negative 3 plus 8. What does a equal? So if I was to rewrite this, P of x equals negative 3x squared minus 14x plus 8. If I put 1 into the equation, I will get negative 9 as an answer. Okay? Question 9, which is our last question. Determine the values of A and B in the following equation if P of 2 equals negative 18 and P of negative 3 equals negative 13. So if I substitute 2 into the equation, I will get negative 18 equals negative 2 times 2 squared plus 2 times A plus B. So 2 squared is 4, and 4 times negative 2 is? And when I bring the negative 8 to the other side, it will become?
Negative 10.
Hey, I need that over.
So negative 10 equals 2A plus B. If I replace x with 3, negative 3, I get negative 13. So negative 2 times negative 3 squared plus A times negative 3 plus B. So negative 3 squared is 9. 9 times negative 2. Bring the negative 18 to the other side, it becomes positive, and then I get positive 5. So 5 equals negative 3A plus B. How do I solve for A and B? Actually, yep. Those are my two equations. What could I do with those two equations to solve for A or B? It goes back to grade 10. What would happen if I subtracted the two equations? I'd have no B's. I would just have an A, and then I could solve for that A. So do that. So negative 10 minus 5 gives me negative 15. 2 minus negative 3, I get 5. And B minus B is 0. So what does A equal?
It's 2 minus
Negative 3. And then to find B, I can put it into one of those two equations. 5 equals negative 3 times negative 3 plus B, which is 9. So what does B equal?
Negative 4.
And it would equal the same thing if I put it into this equation. Negative 3 times 2 is negative 6. Bring it to the other side, I would still get negative 4. So I can go back and I can use my system of linear equations to solve this as well. The key point that they're stressing in this class example is just that substitution, that understanding that I need to put 2 in for x and that it would equal negative 18. So the questions for you, 1,